Okay, we're back in section 7.8, and there are a few types of word problems in this section. But the main ones that we're going to go ahead and focus on, the main type of problems, there's only going to be can find about 8 or 9. And this is going to require us to isolate a variable or to solve in an equation that contains nothing but variables or primarily variables. It's going to ask us to isolate one variable in particular. So that's a little easier said than illustrated. So let's tell you what that means. So if I have f is equal to L divided by D, and I'm asked in the problem to solve for D, that means I'm asked to get D by itself. So what I'm being asked to do essentially is to get D alone. So what I'm going to do in order to help that happen in this question is I'm going to go ahead and write out this problem again. And I want to get D on the top somehow. I don't want the D in the bottom. So I'm going to go ahead and multiply both sides by D over 1. When I do so, I'm going to get FD equals L. Here, if I multiply through, the D is going to cancel. So I'll have F times D is equal to L. Now if I want to get D alone, I'm going to simply divide by F, and D will equal L over F. And that's a relationship that we are looking for in this question. Let's take a look now at another problem. So we're going to kind of go through these kind of quickly. As you see, you'll kind of get the gist. But again, there'll only be 1 or 2 on the test. They're not going to be worth a whole lot. Not the end of the world if you really, really struggle with these. But hopefully we can give you the help in class and in tutoring to become masters of these and feel comfortable with them. So we have the variable s is equal to the quantity of v sub 1 plus v sub 2 times t over 2. So in these problems, what we have here, these 1 and 2's don't necessarily have any meaning. They're often just used kind of like as labels, like if we're labeling something from a point or something like that. So it's not that we have to carry out some operation. They're just used to distinguish between these two values here. And we're supposed to solve for v1. So this is how we're going to do it first. Like all the other work we've done before, we're going to go ahead and we're going to get rid of the fraction. So the one thing we're trying to solve for, we're trying to solve for this. This is what we're trying to get alone. So what I'm going to go ahead and do to begin the problem, so let me just start by writing this over again. Then I'm going to go ahead and multiply everything through by 2, which means I'm going to get 2s is equal to v1, the quantity of v1 plus v2 times t. Next, I have this t on the outside here. I'm going to go ahead and divide everything by t. So that's going to give me 2s over t is equal to v sub 1 plus v sub 2. Now that I don't have a t on the outside of that anymore, I do need to carry through the parentheses. So if I want to get v1 by itself, all I need to do is subtract v sub 2 from both sides. So that's going to give me 2s divided by t minus v sub 2 will give me v sub 1. And now I have the equation solved. So those ones with parentheses usually tend not to be the student's favorite. It's easy to make mistakes on those types of problems. But let's go ahead, let me show you some more examples so that you can get more practice with this. And we're going to go ahead and keep going forward. 17. We have t over a plus t over b equals 1. And we're actually asked to solve for b. So we're asked to get b by itself here. And this is going to be a lot of fun too. You'll see why here. Well, remember, we want to get rid of the fractions here, so we're going to go ahead in this problem. We're going to rewrite it again. And we're going to multiply everything through by ab. Specifically ab over 1. When I multiply this, the a's are going to reduce, giving me bt. When I multiply this through, the b's reduce, giving me AT. Next, if I multiply AB times 1, that's going to give me AB. And this is another problem that students typically do not like, because we have the B appearing twice in the question. So what I'm going to go ahead and do is get all the terms that have B over to one side. So looks like I've got this here, so I'm going to subtract BT from both sides. So we'll have AT is equal to AB minus BT. So a little bit out of order, but nothing we can't rectify. But now what we need to do is, because both of these terms contain a B, I need to go ahead and factor that out. So I can write this as AT equals B times A minus T. So I'm factoring a B because there's a B in each term here. And now if I want to get B by itself, I divide both sides by A minus T. And that's going to give me AT over A minus T is equal to B. And I now have isolated B and I solve for B. Next question. Let's go ahead and take a look at 19. So we have 19. Big R. Or excuse me, nope, that's not how it starts. Let's start this way. The big I is equal to 2V over big R plus 2 little r. We're being asked to solve this in terms of R. So hopefully you have some idea where I'm going to be going with this, because I do want to bring this up on top here. I'm going to go ahead, since I want to solve for R, I'm going to go ahead and I'm going to multiply everything through, well, once I write it again. I'm going to multiply everything through by the big R plus 2R, and I'm going to do that on both sides. Hopefully you see when you multiply this, it's just going to be I times R plus 2R. Here they're going to reduce, giving me just 2B. Now I'm trying to get this by itself, so I'm going to divide both sides by I. This is going to be, don't need the parentheses anymore, R plus 2R is equal to 2V over I. Finally, if I want to get this by itself, I have to subtract 2R from both sides, 2 little r. But finally, I'm going to get R is equal to 2V over I minus 2R. So what we have here, we've essentially seen all the techniques that we're going to be using for this work here. But we're going to continue to go over these problems so you begin to get more comfortable with these techniques. So we're going to go ahead and keep going with these problems here. So let's take a look next at 21. 21 is going to be R is equal to the quantity of G times S over G plus S. And in this problem we're asked to solve for G. So we're trying to get G by itself, so just like we did in question 19, let's go ahead and rewrite this again. We're going to multiply through to get rid of the denominator. Here this is going to give me R times the quantity of G plus S equals GS. Well, since we're trying to solve for G, we're not going to just go ahead and divide by R, because we can't leave this G here. We're actually this time going to multiply R through. So we're going to have capital R times little g plus capital R times S equals GS. So what I'm going to do is I'm going to get the G's all together on one side. So I'm going to subtract our G from both sides to get RS equals GS minus RG. My next step is to factor G out. So we have RS is equal to G times S minus big R. And since I want G by itself, I have to divide both sides by S minus R. So we have R S over S minus R equal to G. And that's going to be the value of G in the problem there. Okay, let's go and we'll do question 23. Following along with these new fun techniques that you guys are learning here. We have 1 over P plus 1 over Q is equal to 1 over F. And in the question, we're asked to solve for Q. So what we're going to do is we're going to go ahead and multiply everything through by P, Q, and F. We get rid of the fractions altogether. Now, fractions are invariably going to come back. There's no way of avoiding it. But we're going to multiply this through by P, Q, and F over 1. So this is going to give me, the P gets eliminated, so it's going to be QF. Here the Q gets eliminated, so it's going to be PF. And here the F is going to get eliminated, so it's going to be PQ. Well, since I want to solve for Q, that means I have to organize all the terms that contain a Q. We have a PQ over here, so I want to subtract QF from both sides. Hopefully this is becoming a little easier. PF equals PQ minus QF. And again, these terms have a Q, so it's going to be Q times P minus F over PF. And this looks real similar to a problem we did a little while ago. P minus F. So we have P times F over P minus F equals Q. And that's going to be our final answer for 23. And anytime when you see me try these questions and you want to see if you can do them, feel free to pause and stop the video to, see what the question looks like, try it first, and then you can have my work on here confirm whether you got it right or wrong. Let's make sure we got this censored on the screen properly here. And we got question 25. Doing as many of these as I can to help you guys out. S is equal to capital H over M times T1 minus T2. And in this case, we're being asked to solve this for T1. So what I'm going to do in this question is I want to get rid of the denominator in its entirety. So I'm going to multiply this by M times T1, T sub 1 minus T sub 2. When I multiply the S by that, that's going to be S times M by T sub 1 minus T sub 2 equals H, because this is going to cancel all together. Next, I want to try to get T sub 1 minus T sub 2 by itself. So I'm going to divide both sides by SM. So if T sub 1 minus T sub 2 equals H over SM. And now if I want to get T1 by itself, I'm going to add T to the both sides. Well, I'll get T sub 1 equals H over capital SM plus T sub 2. And now that's done. So you're going to see a lot of these techniques kind of reemerging again and again and again. So we'll go through a few more questions before we call it an evening. 27. This is going to be capital E over little e. It's going to equal capital R plus little r over r. And you probably guessed we're going to go ahead and solve this for little r, because that's the fun one. So we have an E, we have an R, so we're going to multiply this by ER. So the E is going to cancel here, so we're going to get E little r. And this is going to be, when we do this now, the R is reduced, so it's going to be a little e times R plus big R plus little r. So since we're solving this for R, we're going to go ahead and want to distribute this through. We're going to have capital ER equals little e capital R plus ER. So we distributed the E through here. We want to solve for r, so we're going to move everything that contains a little r. This and this, we want this together. So I'm going to move a little er. This is going to be capital ER minus ER equals, and to hear me say this, guys, doesn't do it justice because all the freaking letters are the same, only difference is whether they're capital or little. So you really need to watch the work on this here to be careful. This is the kind of stuff mathematicians dream about tormenting with you guys with at night. Not me. It's just job security for me. Now that I factor the r out, I can divide both sides by big E minus little e. And r equals E, capital R, over big E minus little e. And that is done. So we're going to go ahead and we'll just, yeah, you know what? I think that's going to be it. If you've seen all the techniques here, you need to kind of help you out with this. The rest of these you can do, or you can ask questions on a class. I understand when you see this the first few times, this may be a little confusing, but once again, I'll be glad to go over these techniques in class to clarify the properties that we're going to use, and hopefully you can tie this work back to the work that was done in 7.6. Have a good evening.